1938, America is crawling out of the Great Depression. Gasoline rules the roads, steam still hauls freight, and diesel, it's seen as too heavy, too industrial, too impractical for trucks or buses. Yet, at General Motors, a quiet revolution is underway. A team of engineers, led by Charles Kettering, dares to imagine diesel powering not just factories, but buses, tanks, and locomotives. Skeptics laugh, steam roars past, but in secret workshops, GM builds engines that leak oil and refuse to die. By the time American troops storm Pacific beaches, these compact diesels are everywhere, in landing craft, tanks, generators, and supply convoys. They survive where others fail. War proves their toughness, but a new challenge awaits: America's highways, city streets, and long-haul trucking. Could these engines dominate peace as they did battle? How did Detroit diesel turn a risky gamble into the backbone of American transportation, and later a high-tech global powerhouse? That story starts here. Let's step back in time to America in 1938. Ford and Chevrolet ruled the roads with gasoline engines. Steam locomotives still hauled freight across the continent. To most Americans, diesel meant ship engines, heavy, leaky, and far too industrial for trucks or buses. General Motors saw something different. While competitors focused on refining gasoline engines, GM executives made a decision that seemed reckless. They would build an entire division around diesel technology, not just one engine, but a complete family designed to power everything from city buses to military vehicles. Product development gave way to industrial warfare. The company established the GM Diesel Division in 1938, creating a dedicated unit focused entirely on promoting and supporting diesel engines across multiple sectors. But GM's strategy went deeper than marketing. They pursued diesel across three coordinated lines: Electromotive for road locomotives, Detroit Diesel for compact vehicle and industrial use, and Cleveland Diesel for larger marine engines. This vertically integrated approach controlled everything from engine design to customer service, merging Winton Engine Company into Cleveland Diesel for marine applications, while launching Detroit Diesel for trucks and buses. Charles Kettering, who headed GM's research division, believed existing diesel designs were fundamentally flawed. His team developed something radical: compact two-stroke diesel engines that could be easily maintained in the field. These weren't the massive stationary diesels that powered factories. These were lightweight engines designed to fit in vehicles and work under constant stress. The compact Series 71 packed surprising power, capable of running everything from buses to military craft. Its modular design would define diesel versatility for decades. Meanwhile, the EMD 567 locomotive engine, introduced in 1938, and the 1939 FT demonstrator served as the railroad side proving ground for GM's broader diesel program. The resistance was immediate and fierce. Steam still dominated American railroads. Heavy-duty diesels remained experimental curiosities. Marine buyers stuck with proven technology. The perception of diesel as loud, dirty, and unreliable created walls that seemed impossible to break. GM was asking entire industries to abandon proven gasoline technology for engines most people associated with construction sites and ships. The timing made the gamble even more dangerous. America was crawling out of the Great Depression. Companies couldn't afford expensive mistakes. Launching an entirely new engine technology with uncertain demand could have bankrupted the division before it proved itself. Detroit Diesel faced enormous pressure to demonstrate real-world success quickly, or watch the entire project collapse. By weaving its operations together, GM established a competitive edge that others couldn't replicate. While other companies built engines and hoped someone else would figure out how to use them, GM designed complete diesel-electric systems that railroads and shipyards could adopt with confidence. They offered buses with engines specifically engineered for city routes and provided marine packages that eliminated guesswork. In the heat of battle, diesel became the soldier's lifeline. The military needed reliable power for tanks, landing craft, trucks, and generators. Steam engines couldn't handle the demands of mobile warfare. Gasoline engines were vulnerable and inefficient. Diesel engines proved they could operate under extreme conditions while delivering consistent power. Detroit diesel engines powered American landing craft storming Pacific beaches. They drove tanks across European battlefields. They kept generators running in forward bases and supply depots around the world. Roughly 57,671 engines were installed in U.S. landing craft, and roughly 39,000 Series 71 engines went into armored vehicles, including twin-pack installations in M4A2 Shermans. The Series 71 engine earned an anecdotal reputation for leaking oil, but continuing to run under punishment that would destroy other engines. Under fire, diesel proved itself where numbers alone couldn't convince. Military officers relied on it for tanks and landing craft, while industrial managers finally saw engines survive conditions gasoline could not. Fleet operators began tallying fuel savings and service intervals. Skepticism evaporated in the heat of battle. By 1945, Detroit Diesel had established itself as more than just an engine supplier. The company had become a key industrial and military contractor, with a reputation for building engines that worked under impossible conditions. The Series 71 laid the foundation for diesel dominance in heavy-duty markets that would last for decades. The bold gamble had survived the crucible of war, but a different test awaited on America's expanding highways, terrain that demanded endurance in everyday life rather than combat. On July 22, 1956, President Eisenhower signed the Federal Aid Highway Act. Few people realized that signature would transform engines as much as roads. Suddenly, freight that had moved by rail began shifting to highways. Cities expanded into suburbs connected by ribbons of concrete stretching from coast to coast. Detroit Diesel found itself perfectly positioned to power this transformation. The Series 71 engines that had powered landing craft and military vehicles adapted seamlessly to civilian applications. These compact two-stroke diesels, with their modular design allowing various cylinder configurations, found new homes in city buses, highway trucks, construction equipment, and marine vessels. The symmetrical block design that had proven valuable in cramped military vehicles now served fleet operators who needed engines that could be serviced quickly in depot maintenance bays. When transit authorities needed buses that would start every morning and run all day in city traffic, they chose Detroit Diesel. The GM New Luck bus, produced in 1959, became an icon of urban transportation, with many powered by Detroit's 6V71 engines that delivered the reliability city fleets demanded. Construction companies bidding on highway projects specified Detroit Diesel because they knew these engines would keep running in remote locations where breakdowns meant missed deadlines and lost contracts. GM positioned Detroit Diesel as the backbone of America's mobility revolution, expanding beyond simple engine sales to become a complete powertrain solutions provider. The company worked directly with manufacturers to design engines into vehicles rather than simply installing them. This integrated approach meant Detroit diesel engines were optimized for their specific applications, whether powering cross-country trucks or urban transit systems. Peacetime introduced a new set of challenges: rising fuel costs, the need for long-haul reliability, and competitors ready to capitalize on any weakness. Cummins emerged as a formidable competitor, promoting four-stroke engines that promised better fuel economy. Caterpillar leveraged its construction equipment dominance to push into the over-the-road trucking markets. These competitors questioned whether Detroit's two-stroke technology could meet the evolving demands of long-haul trucking, as highways stretched longer and loads grew heavier. The reliability equation became more complex in civilian markets. Military operations had accepted frequent maintenance and occasional oil leaks as the price of battlefield durability. Civilian fleet operators calculated the total cost of ownership differently. They wanted engines that delivered consistent performance with predictable maintenance intervals. Detroit's two-stroke design, while compact and powerful, developed a reputation for oil consumption that competed with its legendary toughness. The rise of interstate trucking pushed the limits of logistics in ways that even the military had never imagined. Highway speeds remained constant for hours. Gross vehicle weights increased as trailer designs improved. Routes stretched across entire regions without the supply infrastructure that had supported military convoys. Fleet operators needed engines that could handle sustained high-power operation while delivering fuel economy that justified the switch from gasoline. Detroit Diesel responded by expanding its engine family and developing configurations that addressed specific market needs. The Series 53, introduced in 1957, became the company's first engine developed specifically for on-highway applications, demonstrating Detroit's commitment to civilian markets. Detroit's modular engines, inline or V-type, from single cylinders to multi-cylinder giants, meant city delivery trucks, long-haul tractors, and industrial machines could all share parts and service infrastructure. The cultural impact reached beyond commercial success. The characteristic two-stroke bark became the soundtrack of American trucking, a distinctive whine that announced the approach of a Detroit-powered truck from miles away. This sound became part of trucking identity, as recognizable as the chrome and paint schemes that decorated highway rigs. Despite quirks, Detroit engines proved themselves on the road, winning loyalty from drivers who depended on them every day. They built trust with operators who depended on their equipment every day. Drivers knew that a Detroit might require attention, but it would keep running when stopping meant missing delivery schedules. By the end of the 1960s, Detroit Diesel had woven itself into American transportation culture, successfully transitioning from wartime contractor to civilian industry leader. But the company's influence extended far beyond highways and city streets into territories that demanded even greater versatility and toughness. The 1960s found Detroit Diesel at the peak of its power. Under General Motors ownership, the company dominated trucking, buses, construction, and marine markets with engines that had proven themselves in war and peace. Detroit Diesel's victories looked impressive from the outside, but hidden beneath were fuel headaches and looming rivals. Detroit Diesel broadened its lineup. The Series 71 continued as the transit bus mainstay. The Series 53, 1957, targeted on-highway service, and the Series 92, 1974, delivered higher horsepower for demanding applications. GM positioned Detroit Diesel as the go-to solution for reliable diesel performance across industries. The broader GM diesel strategy had reached maturity by 1960, with dieselization of U.S. railroads essentially complete. This allowed GM's multi-pronged diesel program to settle into distinct post-war specialities. Electromotive division dominated rail locomotives, Detroit Diesel focused on on-highway and off-highway applications, and Cleveland Diesel handled marine engines. Each division could concentrate on perfecting technology for its specific markets. General Motors invested heavily in research and development, establishing Detroit Diesel as the innovation leader in two-stroke technology. The company's engineers refined combustion chambers, improved fuel injection systems, and developed new configurations that pushed the limits of two-stroke design. Detroit diesel engines powered the iconic GM transit buses that became fixtures in American cities. This dominance created a brand identity that transcended mere mechanical reliability, with Detroit diesel engines becoming symbols of American industrial strength, built on decades of proven performance from World War II battlefields to interstate highways. Fleet managers chose Detroit Diesel not just for technical specifications, but for the confidence that came with engines that had never failed when failure meant disaster. But the 1970s brought pressures that would shake this foundation. The fuel crisis transformed fleet economics overnight. Operators who had prioritized reliability above all else suddenly demanded engines that delivered maximum fuel efficiency. Every gallon counted when diesel prices spiked and profit margins disappeared. Detroit's two-stroke engines, designed for power and durability, consumed more fuel than the four-stroke competition. This efficiency gap became a strategic weakness that competitors exploited relentlessly. Environmental regulations created an even greater challenge. The Clean Air Act and subsequent emission standards exposed fundamental limitations in two-stroke design. These engines burned oil as part of their normal operation, creating visible exhaust smoke that regulators and the public increasingly rejected. While Detroit diesel engineers worked to reduce emissions, the basic architecture made clean combustion extremely difficult to achieve. The 1970s fuel shocks and tightening emission standards changed fleet economics and raised serious questions about the two-stroke architecture's fuel consumption and emissions profile. Competition intensified from multiple directions. Foreign manufacturers began offering engines that combined efficiency with reliability. The durability that once earned Detroit Diesel its reputation now drew scrutiny. Green leakers, as drivers joked, burned oil while performing reliably. A liability in an era of fuel economy and emissions regulations. Detroit Diesel attempted to adapt without abandoning its core technology. The company expanded the Series 92 to meet higher horsepower demands from long-haul truckers operating under interstate weight limits. Engineers developed refinements to reduce emissions and improve fuel efficiency within the constraints of two-stroke design. Detroit managed strong positions in transit buses and vocational trucks, where operators valued reliability over efficiency concerns. Even with new technologies, old constraints and rising competitors meant the road ahead was anything but certain. The company began losing market share in the crucial heavy-duty on-highway sector, where Cummins and other four-stroke engines offered compelling advantages. Unlike military or municipal buyers, fleet operators focused on total operating costs. Fuel economy and emissions compliance shifted from optional considerations to mandatory standards. Detroit Diesel needed a miracle, and it came in the form of revolutionary technology that would redefine heavy-duty trucking forever. By the 1980s, Detroit Diesel's once dominant two-stroke designs were losing ground to Cummins and Caterpillar's efficient four-strokes, leaving the company struggling to survive. Could Detroit Diesel reinvent itself before becoming another casualty of industrial change? The answer came in 1987 with the Series 60, launched as Detroit's first engine designed from the ground up for full electronic control through DDEC, an inline-six four-stroke that pivoted the company away from its two-stroke legacy. The Series 60 marked more than a design shift. It transformed trucking from mechanical know-how to electronic precision. The technology behind the Series 60 centered on the Detroit Diesel Electronic Control System, known as DDEC. This computer brain continuously monitored performance, adjusting fuel injection in real time. The system tracked operating parameters that human drivers couldn't sense, optimizing combustion for maximum efficiency while protecting internal components from damage, and also storing fault codes that mechanics could read with diagnostic equipment. The transition proved smoother than expected because DDEC had debuted on two-stroke engines in the mid-1980s, with DDEC introduced around 1985, which helped fleet acceptance of Series 60 electronics by familiarizing operators with the diagnostic technology. Truckers faced a new kind of engine, one guided by electronics rather than wrenches, hauling millions of dollars of cargo over thousands of miles. The company was betting its future on technology that most truckers viewed with deep suspicion. The risks were enormous. Fleet operators feared electronic complexity in an industry built on mechanical simplicity, where reliability meant the difference between profitable operations and bankruptcy. Electronic controls meant higher initial costs and potential repair bills that could dwarf traditional mechanical problems. The trucking industry had always valued equipment that drivers could fix with basic tools beside remote highways. This untested experiment required more than just product innovation. Detroit Diesel Corporation restructured itself with a new governance model when the GM-Penske joint venture formed on January 1, 1988, with Penske holding majority control. This alignment of commercial focus with the Series 60 launch linked product and corporate reinvention, positioning the company to compete aggressively in markets that demanded both reliability and efficiency. On the open highway, under full loads and tight schedules, the Series 60 quietly proved that electronics could outperform muscle. The electronic controls delivered better fuel economy than competitors during years when diesel prices made efficiency crucial for fleet survival. The four-stroke design produced fewer emissions, meeting tightening environmental regulations that two-stroke engines couldn't satisfy. DDEC diagnostics simplified fleet maintenance by identifying problems before they caused roadside breakdowns, saving time and money for operators managing hundreds of vehicles. Reliability improved dramatically as electronic controls prevented the operator errors and mechanical abuse that had destroyed engines in the past. The system wouldn't allow drivers to over-rev engines or operate with low oil pressure. It monitored coolant temperatures and adjusted performance to prevent overheating damage. Fleet managers discovered that electronic controls actually increased reliability by protecting engines from conditions that mechanical systems couldn't detect until damage occurred. By the 1990s, the Series 60 had become the best-selling heavy-duty engine in North America. Fleet operators who had initially resisted electronic controls now demanded them as standard equipment. The engine that truckers had feared for its complexity became the industry standard for reliability and efficiency. Detroit Diesel had successfully transformed from a company known for tough but thirsty two-stroke engines into a leader in modern engine technology. Where drivers once hesitated, the Series 60 set the new standard, showing that practical innovation could conquer deep-seated industry resistance. The engine saved Detroit Diesel from extinction and established the foundation for future growth. But this remarkable turnaround was only the beginning. As the new millennium approached, Detroit Diesel's proven technology and renewed reputation would attract the attention of global automotive giants, seeking to expand their reach into the lucrative North American trucking market. In 2000, Daimler Chrysler acquired Detroit Diesel Corporation and integrated Detroit into Daimler Truck North America, marking the beginning of a transformation that would reshape the company's identity and capabilities. This wasn't just another corporate acquisition. Daimler was building a global network of commercial vehicle companies, and Detroit Diesel would become a crucial piece of that worldwide puzzle. Daimler aimed to convert Detroit Diesel into a full powertrain division, integrating engines with transmissions, axles, and electronics into seamless packages. Instead of selling individual components, Detroit would offer complete drivetrain solutions designed to work seamlessly with Daimler's truck brands. The expansion strategy created the unified Detroit brand identity that covered much more than engines. Detroit transmissions, Detroit axles, and Detroit telematics systems would complement Detroit engines in Freightliner and Western Star trucks. This integration allowed Daimler to control the entire powertrain experience, from initial design through customer service. The practical result delivered fleet-level advantages. Detroit engines, Detroit automated transmissions like the DT12, and Detroit axles were calibrated as an integrated powertrain in Freightliner Cascadia packages, offering total cost of ownership benefits that competitors couldn't match with components sourced from multiple suppliers. The Series 60 remained Detroit's flagship engine during the early transition years, with production continuing until 2011 as Detroit shifted to the DD platform. Daimler invested heavily in developing the next generation of power plants through its heavy-duty engine platform strategy. The DD15 launched in 2007 as the North American expression of a global inline-six family, followed by the DD13 and DD16 engines designed specifically for efficiency, emissions compliance, and global adaptability. These engines incorporated advanced technology from Daimler's worldwide research network, combining Detroit's durability heritage with German engineering precision and global manufacturing capabilities. The regulatory landscape drove significant technological changes during this period. EPA 2007 standards pushed the industry toward exhaust gas recirculation and diesel particulate filters, but EPA 2010 NOx controls required a fundamental shift to selective catalytic reduction technology. Detroit's BlueTech SCR system offered fuel economy advantages over high EGR approaches, with fleet-level estimates showing 3 to 5% gains in early comparisons. This transition demonstrated how regulatory pressure could drive innovation that benefited both environmental compliance and operational economics. Daimler's ownership gave Detroit Diesel access to resources that independent companies couldn't match. Global research facilities share technology across continents. Manufacturing plants could produce engines for multiple markets using common components and processes. Distribution networks reached markets that Detroit had never served as an independent company. This scale created advantages in development costs, manufacturing efficiency, and market reach. Joining a global network required balancing American trucking culture with German engineering standards, a challenge for both corporate and customer relationships. Fleet operators who had built relationships with Detroit Diesel over decades wondered whether German corporate control would change the responsiveness and support they valued. The challenge was maintaining Detroit's American trucking identity while adapting to international corporate requirements. The Detroit brand identity expanded beyond engines to encompass complete powertrain and technology solutions. Detroit Connect telematics systems provided fleet management capabilities that helped operators optimize fuel consumption, maintenance schedules, and driver performance. This transformation positioned Detroit as a technology leader rather than just another engine supplier. Detroit had reinvented itself before. Now, the challenge was scaling that ingenuity across continents and cultures. The foundations were in place for whatever changes lay ahead. Today, Detroit Diesel's influence isn't measured just in horsepower or production numbers. It's measured in memories. Ask anyone who ran a two-stroke Detroit what they remember, and chances are they'll start with the sound. That high-pitched whine echoing off city streets, mounting grades, or mine walls. For some, it was a comfort. For others, an irritation. But for everyone, it was unmistakable. Mechanics still joke that Detroit's marked their territory with oil stains. Yet the same mechanics will tell you those engines always brought trucks, buses, and equipment home, no matter the conditions. That combination of quirks and reliability gave Detroit a cultural footprint few engine makers have ever achieved. The legacy isn't just technical, it's personal. Long-haul drivers, construction crews, and marine operators built their livelihoods on these engines. To them, Detroit wasn't just a brand stamped on a valve cover. It was a partner in the work, part of the rhythm of everyday life. And as the brand pushes forward into electric power and digital telematics, it carries not just a name, but an entire identity, shaped by generations of operators who trusted the hum of a Detroit to get the job done. In 1938, GM's diesel gamble looked reckless. Gasoline was king, and few believed diesel had a place on American roads. 8 decades later, Detroit diesel faces a moment that feels strikingly familiar. The industry is shifting again, this time toward batteries, electric drivetrains, and zero-emission trucking. Once, Detroit asked truckers to trust computers with their livelihoods. Today, it asks them to trust electricity with the future of freight. The risks are just as real, and the skepticism just as strong. But history shows that Detroit has thrived when it leaned into bold bets. Whether the E-Cascadia becomes the next Series 60 or a forgotten experiment remains to be seen. What's certain is that Detroit Diesel's story has never been about playing it safe. It's about taking gambles big enough to change the way the world moves. Let us know which Detroit engine you ran, 671, 6V92, Series 60, DD15, and we'll bring that engine story to the foreground next time. Don't forget to subscribe for more stories like this one. Until the next one.